A revolution in room heating. Is there an alternative to radiators and underfloor heating? This CPD discusses the advantages and potential disadvantages of thermal skirting in residential, healthcare, student and assisted living, as well as commercial environments. Topics covered include: what is thermal skirting, radiant heat versus convectors, space and energy saving, working with heat pumps as well as boilers, electric versions, carbon emissions and embodied carbon, low surface temperature requirements, health and safety, response times and overheating, construction savings including weight loadings, how to specify and where not to. What is thermal skirting? Thermal skirting combines the heating and skirting board into one construction element. Manufactured from an aluminium polymer, the skirting acts like a radiant panel, heating the room from low level and potentially from all directions. The heat source can be water-based, either a boiler or heat pump, or direct electric. The total heat output is directly proportional to the operating temperature and the surface area. As a result, profiles are available in different heights to ensure sufficient heat is provided even if insulation levels are poor or the operating temperature is reduced, such as with heat pump or low surface temperature requirements. Various controls can be provided. For example, a mechanical valve similar to radiator TRVs for a simple manual operation, a 2-port or capillary valve for remote operation, back to manifold like underfloor heating, or even a direct electric thermostat control like a panel heater or electric underfloor heating. For larger projects, special profiles and colours are available to suit the style and decor of the development, including shades of grey, black, silver and other popular finishes to match the windows and facades. Summary: combines the skirting and heating in one, saving cost and space. Suitable for boilers, heat pumps and direct electric. Available in a range of styles, heights and colours. Available with mechanical and programmable digital controls. Radiant heat versus convection. Radiant heat, or far infrared heating, is becoming widely recognised as a more comfortable and healthier form of heating than convection. Usually, this has meant using underfloor heating rather than radiators, or potentially infrared panels on the ceilings or walls. Being made from an aluminium alloy, thermal skirting acts like a radiant panel when heated, but feels like underfloor heating in most applications, as it radiates from low level and from several directions at once. Being a smooth surface, there are no grills and fins to pick up dust and spores from floor level, and so hygiene and cleanliness is greatly improved compared to a convector radiator. Summary: true far infrared radiant heat, manufactured in a highly efficient aluminium polymer, minimum convection currents to avoid drafts and cold spots, no slots or grills to harbour dirt and infection. Space and energy savings. Space. With more and more projects focusing on maximising usable space, eliminating wall-hung emitters is seen as the most obvious improvement. This has usually meant some form of floor, ceiling or even wall heating. Embedding pipes or heating elements into the structure of the building may introduce other considerations such as weight loading, pipe runs, choice of floor coverings, response times and even overheating concerns. Combining the heating into a skirting profile increases usable floor space without these concerns due to its inherent low thermal mass, ease of accessibility for installation, maintenance or troubleshooting. Energy savings. The elimination of convection currents in favour of radiant heat has been recognised as improving the comfort of occupants and therefore providing potential energy savings. The Energy Saving Trust states that if thermostats can be set to 1 degree C lower, this can result in a reduction in energy consumed of about 6%. Much research has been done into the cooling effect of convection currents and the wide variation in temperatures across a room. These cooling convection currents are eliminated with radiant heating and thus comfort levels improved at lower energy levels. Response times are significantly quicker than heating systems embedded into the structure and are unaffected by surface coverings. As a result, closer control of the heating on and off can be achieved. This too can assist in saving energy over the daily, weekly or seasonal cycle, as the heating can more closely track the demands of the occupied space. With a greater potential surface area and better distribution of the heat, it is often practical to operate thermal skirting at lower flow temperatures than conventional radiators. Typical radiators are sized to operate at delta T 50C, which will require a boiler flow temperature in excess of 70 degrees C. Thermal skirting can allow conventional boilers to operate at 55 degrees C or less, which will improve the efficiency of the primary heat source and ensure it is always in full condensing mode and not just during a cold startup. Summary. Removing the emitter from the wall adds value and versatility. Improved comfort can encourage energy savings. Closer controllability minimises energy usage. Lower operating temperatures improve boiler efficiencies. Weather compensation and variable flow temperatures are easily accommodated. Working with heat pumps as well as boilers. With correct sizing, thermal skirting can work effectively on a heat pump, creating the possibility of retrofitting existing properties as well as new ones with renewable low-carbon technologies. Ground or air source heat pumps are replacing gas and oil boilers or storage heaters in many new build and retrofit projects. The emitter becomes much more important when the property may have limited wall space or is part of a multiple dwelling development such as apartments. Heat pumps generally require much larger emitters such as oversized or fan-assisted radiators or underfloor heating. These can present space, design and construction considerations that are not necessary when using thermal skirting. Low water volume compared to oversized radiators and underfloor heating enables thermal skirting to maximise the COP of heat pumps by reducing the rate of decay in any thermal store. Thermal skirting can be combined with radiators and underfloor if appropriate, for example if extensive tiled or hard surfaces are used in some areas, or tile radiators in the bathrooms. Summary. Practical installation, even retrofit applications, can assist the take-up of heat pump technologies. Lower operating temperature can help the performance of the heat pump. Low water volumes can assist rapid thermal store recovery times. Low water volumes and faster heat-up times can allow resizing of HIUs and pump sets. Electric thermal skirting. The increase of renewable electrical energy means that for many developments, electrical heating is a viable option under SAP 10 and many local authority building control. The relative simplicity of the all-electric system in terms of installation and troubleshooting means that thermal skirting is a suitable alternative to panel and storage heaters. With high levels of building insulation and the required Lot 20 controls, which have additional features such as occupancy detection or window monitoring, it is possible to reduce the running costs to a level acceptable to the homeowner or tenant. Thermal skirting also has the ability to be switched into half power mode on startup. This is particularly beneficial when the occupied space is hovering around the target temperature. Upon reactivation, the half power mode provides just enough heat energy to return the room back to the target temperature, but avoids overshooting and thus wasting energy. Finally, the ramifications of the Grenfell Tower disaster are still being felt, with new government legislation in the pipeline for building safety. Thermal skirting can also incorporate a fail-safe heating element that will not overheat even when covered over. This fire safety feature is likely to be a factor in building fire countermeasures. Summary. Particularly suitable for apartments and modular construction. Very controllable and thus economical to run. Half power function to avoid overshooting. Fire safe heating element which will not overheat. Thermal skirting is available in identical profiles in either wet or electric for simplicity of design and specification changes. Carbon emissions and embodied carbon. A report by Drax has compared the UK's average gas boiler mix with the average grid electrical generation mix. It shows that the average efficiency of a gas heating rose to just over 86% in 2019, such that carbon emissions from producing 1 kilowatt of central heating fell to 250 grams of CO2. However, simple electric heaters average only 207 grams of carbon dioxide per kilowatt hour of heating by the end of 2009. This is due to the increasing use of renewable energy such as wind and solar. The report concludes that Britain has reached the point where it's cleaner to use electric heating than a gas boiler. This has resulted in virtual parity between fossil fuels and renewables as a proportion of the UK grid energy generation. The cost of electrical energy is still typically 4 times the cost of network gas, around 16 to 18 pence per kilowatt hour versus 4 to 5 pence per kilowatt hour for gas. As a result, gas-powered wet central heating is still the preferred option for many developers due to consumer pressures to control energy costs. However, much of the energy and thus CO2 emissions of a heating system are generated during startup as the water and emitters get up to temperature before heating the occupied space. A recent assessment by RKCPS Consulting modelled the energy consumed and thus CO2 generated by thermal skirting compared to other popular forms of room heating. The model assumed wet central heating for all 3 solutions. In a steady state, over a typical heating season of 168 days, all 3 technologies were broadly equal, as you would expect with the defined and consistent heat loss. However, when typical occupancy usage was factored in, the differences in energy consumed and thus CO2 generated is stark. 2 typical scenarios, a 10-hour per day operation and a very typical 2 heating cycles of 2 hours and 4 hours were modelled. Radiators and thermal skirting having a comparable water content and emitter thermal mass create much lower levels of CO2 over the heating season due to their low thermal inertia and response times. The embodied carbon is a similar story, although aluminium needs to be produced using renewable energy sources to compete with steel. Eliminating 7 to 9 tonnes of additional concrete screed from a typical 70 metre square apartment also positively impacts the embodied carbon calculation. Being an above ground solution, radiators and thermal skirting also help to avoid overheating, which might require additional measures such as ventilation and cooling, all of which increase the carbon footprint of the project. Finally, with more than 75% of all the aluminium ever produced since 1880 still in circulation, aluminium is the most energy efficient material to recycle. As a result, the end of life costs and embodied carbon of thermal skirting is the lowest overall. Summary. Response times directly impact the CO2 footprint of the development. Low thermal inertia enables close control, maximising efficiency and reducing CO2. Fully recyclable thermal skirting panels reduce the embodied carbon over the whole life cycle. Low surface temperature requirements. Some applications require low surface temperatures to ensure the occupant's safety. These are usually healthcare, mental health and assisted living, where persons with disabilities may accidentally lie against a room heater or deliberately self-harm. In these instances, wall-mounted heaters are often encased in protective covers with grills and slots. If there is a risk of ligature or self-harm, these grills become so small to prevent cords being inserted that they often prevent proper air circulation. This then reduces the heating effectiveness and the surface temperature often exceeds the stated maximum of 43 degrees C. Thermal skirting does not require any protective grills as the heat is radiated evenly along its length rather than convection from a single point, and so an inherently lower operating temperature is possible. With a typical flow temperature of 45 degrees C, or in the case of electric, a low power heating element, the safe surface temperature is assured and the heat distribution maintained. Other benefits such as improved wheelchair space and reduced running costs are in addition to the improved hygiene and elimination of trip or fall hazards than a low-profile skirting heater can provide. Cleaning is a simple wipe down with conventional cleaning equipment, and no special tools and procedures are required to remove covers and grills as would be the case with conventional LST room heaters. Summary: naturally safe surface temperature, naturally anti-ligature, improved hygiene and reduced maintenance. Health and safety. According to the latest ROSPA statistics, there are on average around 29,000 radiator-related injuries every year. Whilst there is a common misconception that radiator injuries would predominantly be scalds and burns, they are in fact a small proportion compared to the impact, trip and fall injuries that are sustained on them every year. Several local authority housing providers are looking to reduce the costs of claims and maintenance repairs by swapping over to thermal skirting. This can not only improve usable living space and make the use of renewables such as heat pumps more practicable, it can enable elderly tenants to stay in their homes for longer rather than go into sheltered accommodation. Assisted living. People living with dementia or challenging behaviour need a comfortable and a safe environment. The smooth and unobtrusive nature of thermal skirting means there is no risk of a fall injury, but also there are no nooks or crannies for fluids or detritus to hide and harbour bacteria or cause unpleasant odours. Clients who might self-harm or damage their living space will have no opportunity to do so if the easy clean high security version developed in cooperation with the NHS is specified. Fast and controllable response time reduce the risk of challenging or violent behaviour due to over or underheating. Student accommodation. With space often at a premium, thermal skirting can release valuable square metres of wall and floor space, as well as reduce the risk of accidental damage to wall-mounted panel heaters, estimated to be replaced or refixed at least once every 5 years in each unit, according to some universities. With no obvious wall heater to hang clothes or sports clothing on, the elimination of damp smells and potentially harmful mould and the risk of a fire is a welcome improvement. Summary: safe in the event of a trip or fall, creates valuable space for equipment such as desks and hoists, simple to clean and no risk of bacteria breeding, resistant to vandalism and challenging behaviour, low surface temperature versions available. Response times and overheating. CPD guidelines TM59 and BRE's overheating in buildings both deal with the relatively recent phenomenon of overheating mainly in multiple dwelling developments. Recommendations include natural cross ventilation, shading or reduced glazing especially on south facing elevations, and in particular lightweight heating solutions. Heavyweight heating systems which are embedded into the floor screed or walls have a high thermal mass and are slow to turn off. This can in turn contribute to overheating. Thermal skirting has a very low thermal mass, typically half a litre of water per linear metre, which means it can heat up and more importantly cool down very quickly. This can help to reduce the risk of overheating. Typical warm-up times from a cold start, 15 degrees C, to a target temperature of 21 degrees C is usually under 30 minutes. A fast response time helps dynamic controls such as Wi-Fi enabled thermostats with learning and distance algorithms to closely control the heating on and off to maximise efficiency. Summary: thermal skirting has a very low water content, improving response times. It does not heat the structure of the building, meaning cooling down begins immediately when turned off. Can help alleviate the need for cooling measures such as mechanical ventilation, air conditioning or shading. Construction savings and weight loadings. At first glance, thermal skirting is a more expensive solution than conventional radiators. However, When whole project costs are considered, the uplift in cost is not so significant and may even provide a small cost saving. Providing the heating, skirting and painting in one element takes out other costs and shortens the Gantt construction chart. Hidden savings such as reduced number of suppliers, confluence of deliveries and space on site all have a cost saving element. As thermal skirting can start at any point in the room, connecting pipe or cable runs can be shortened, rather than having to reach the radiator position, which is usually on an outside wall. Thermal skirting can also come with a removable caulking strip, removing the need for secondary sealing and considerably simplifying decorating. The greatest saving, however, can be in weight. It is calculated that in a 70 metre square apartment, the additional weight of the floor screed for underfloor heating is between 7 and 9 tonnes, based on a 65mm screed. Thermal skirting does not require this additional depth of screed to form the emitter, and so cost of the screed and its application can be greatly reduced. This can result in reduced time on site and a reduction in prelims. The steelwork may be recalculated to reflect the lower weight loading, reducing costs further. A reduction in screed depth reduces curing time and eliminates the need for temporary heating, whilst other trades have unrestricted access as there are no soft surfaces or vulnerable pipes underfoot. Similarly, thermal skirting can be second fixed at many points in the programme, even after floor coverings are laid, improving flexibility and helping to hit PC. Finally, a consistent and perfect paint finish and caulking seal significantly reduces the amount of snagging and rework. Summary: reduces the need for screed and insulation, significantly speeds up the construction process, eliminates the need for curing and temporary heating, combines three elements in one, skirting, heating and painting, allows other trades to work around simultaneously, above ground installation reduces risk of damage and callbacks, works as well with any floor covering. How to specify and where not to. Despite the versatility and flexibility of thermal skirting, it is relatively straightforward to design and specify into most projects, new build, refurbishment or renovation. Thermal skirting, however, cannot solve every heating problem. Applications where thermal skirting may not be suitable include large open plan spaces such as conference rooms and retail halls, very small rooms with limited wall space such as ensuite bathrooms, or indeed where hard surfaces and bare feet may come into contact, as thermal skirting does not heat the floor surface, just the occupied space. Using the online design guide, it is possible to select the appropriate thermal skirting solution by answering a short series of questions that direct the architect, M&E consultant, contractor or client down a route towards the most suitable solution. Starting with primary heat source, i.e. boiler or electric, the guide can quickly lead you to the right product for your application. Technical data. As the performance of thermal skirting is proportionate to its length, there are effectively only 4 profiles to choose from, 2 wet central heating and 2 in electric. Optional decorative cappings can be provided to create the preferred design and style of the project. This makes product selection very straightforward. The table here provides the most important information such as heat output per linear metre at various temperatures. Alternatively, a comprehensive technical data page is available for you to select from, together with technical drawings for incorporation into DWGs, DXFs or BIM models. You can access the performance data tables at this address, discreteheat.com/technical-data.aspx. Thank you for taking part in this CPD. If you have any questions, comments or projects you'd like to share with us, please send them to info@discreteheat.co.uk. Thank you.